Today, we're diving into one of the most sobering and influential events in modern engineering, the Hyatt Regency Walkway Collapse back in 1981. It's a really tragic story about a single catastrophic failure that completely reshaped how we think about public safety, professional responsibility, and even the buildings we walk into every single day. And let's just start with the number, because it's staggering. 114 people. That's how many lost their lives that night. Over 200 more were seriously injured. Even today, it is still the single deadliest structural failure in the history of the United States. So picture this. It's a Friday night. Hundreds of people are gathered in this beautiful, massive hotel atrium for a tea dance. It was a really popular event. You've got these 3 walkways suspended high above the lobby floor, and people are up there watching the party down below. It was just a scene of pure celebration, literally moments before it all came crashing down. Right? So how does this happen? A modern hotel, a totally normal Friday night, and then a complete structural collapse. I mean, there was no earthquake, no bomb, no crazy weather. The structure just gave way. So let's get into how this was even possible. Well, the answer, surprisingly, isn't in the chaos of the collapse itself. It starts way earlier, in a quiet design document. It all comes down to a seemingly small change that was made during construction, a change that would have consequences that no one could have imagined. Okay, so check this out, because the error itself was deceptively simple. On the left, you see the original plan. One long, continuous steel rod was supposed to hang from the ceiling, pass through the 4th floor walkway, and then connect to the 2nd floor walkway below it. Simple enough. But to make construction a little easier, the fabricator proposed the design you see on the right. 2 separate rods. One rod goes from the ceiling to the 4th floor, and then a separate rod hangs from the 4th floor walkway down to the 2nd. That one change. That was it. But it literally doubled the load on the connection holding up that 4th floor walkway. Let's put some numbers to that, because this chart really spells it out. The connection's maximum capacity, what it could actually hold, was about 120 kilonewtons. The original design would have put about 90 kilonewtons of stress on it. Totally fine, well within the safety margin. But the final version, the as-built design, it subjected that exact same connection to over 180 kilonewtons of force. It wasn't just overloaded, it completely blew past its breaking point. So what does that all mean? Well, the conclusion is just chilling. The connections had only about half the strength they needed to have. Failure wasn't just a risk, it was a certainty. From the second that change was made, a ticking time bomb was built right into the hotel's skeleton. It was just a matter of when it would go off. But you have to ask yourself, how on earth does an error like that get through? I mean, this is the scary part. The technical flaw, that little rod change, that was the trigger. But the real story here, the root cause, was a complete breakdown of the entire system of checks and balances that is supposed to prevent exactly this kind of disaster. It was like a perfect storm of procedural failures. You had fragmented responsibility. The architect, the engineer, the steel fabricator, they were all kind of working in their own little bubbles. Communication between them was terrible. The process for reviewing design changes was completely inadequate. And when it came down to it, nobody took full ownership of that change, and nobody did the simple math to see if it was safe. Okay, so a huge part of the problem came down to this one process, the shop drawing review. When the fabricator suggested the easier 2-rod system, the engineering firm looked at the drawings and gave them a stamp of approval. But here's the thing, they treated it like a routine check, just making sure it looked right. They failed to recognize it for what it was, a critical design change that absolutely required a full structural reanalysis. And that reanalysis? It just never happened. And this really gets to the heart of the ethical failure here. The engineering firm of record basically rubber-stamped a fatal design change without doing the math. They delegated the task to the fabricator, but they forgot one of the most fundamental principles there is. You can delegate a task, sure, but you can never, ever delegate the ultimate responsibility for public safety. So after something this horrific, you'd expect big changes, right? And that's exactly what happened. The collapse was a watershed moment. It forced this immense soul-searching that led to profound, lasting changes across the entire engineering profession, and honestly, way beyond it. Out of all that rubble, a whole new framework for safety was built. The industry created new rules, like making peer reviews mandatory for big, complex structures. Formal procedures for quality control and managing changes became standard. The ethical code for engineers was made stronger, And maybe most importantly, this very case became a core lesson in universities everywhere, making sure that future generations would never forget what happened. And the shockwaves just kept spreading. It wasn't just about how we build buildings anymore. It changed legal standards for professional negligence. It tightened up the requirements for professional licensing. It even created new protocols for urban search and rescue teams. Insurance companies, building owners, everybody learned a hard lesson that night. This might be the most terrifying, but also the most important lesson from the whole thing. This wasn't some act of God. It wasn't a failure of some exotic new technology. The building failed under a completely normal load. The failure was in the most basic, routine procedures we have: communication, review, and a simple calculation. It just proves that the biggest dangers are often lurking in the things we do every day, the things we take for granted. This quote from the investigation really just sums it all up. Failures arise not from ignorance, but from the normalization of unchecked assumptions. The engineers knew the math. This wasn't about a lack of knowledge. It was about assuming a change was safe without actually verifying it was safe. It happened because a culture of double-checking had been replaced by a culture of just assuming everything was fine. And that's the question this story leaves us with, even all these years later. In our own work, in our own lives, in all the complex systems we rely on every single day. What are the small, convenient changes we just accept? What are the routine procedures we put our faith in without a second thought? And what unchecked assumptions are we all living with right now?